All right, welcome to what is sure to be the shortest of all the nomenclature videos, the naming of covalent compounds. Now remember when we talked about covalent compounds, a covalent compound forms when two atoms or more share their valence electrons. For example, with water, one hydrogen is sharing one of its electrons, and oxygen is sharing one of its valence electrons. Oxygen does that with another hydrogen by sharing another pair of valence electrons, and now oxygen has a stable octet. Hydrogen has two. Hydrogen is the only element besides helium that is satisfied with having two valence electrons, because that's all it needs to fill that final s orbital. Again, if you don't know what that means, you will soon. But all the same, covalent compounds only form, for the purpose of this class, covalent compounds only form between non-metals. Now, a non-metal is anything, is all these orange tiles here. Typically, if it is on the right-hand side of the periodic table, it's a non-metal. If it's on the left-hand side, it's a metal. Non-metals also include hydrogen. Hydrogen might pretend it's a metal, but it really is a non-metal. So let's talk about naming covalent compounds. Everyone loves naming covalent compounds because it is by far the easiest of all the compounds to name. Because all you have to do is know the Latin prefixes. They might be Greek, but I'm going to say Latin and be wrong. Where 1 is mono, 2 is di, 3 is tri, 4 is tera, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And those prefixes tell you how many of each one of those, of that element, is in the covalent compound, in the molecule. So for example, here I have N2O5, that is nitrogen and oxygen. The second element always gets changed to "ide," so this would be oxide. And now we just have to simply say how many of each one there are. I have 2 nitrogens, so this becomes dinitrogen. I have 5 oxides, so it becomes dinitrogen pentoxide. Notice that I dropped the A. Whenever your anion, whenever your second element starts with a vowel, you can drop the vowel off of the prefix. So for example, oxygen will never have the penta. If you put pentaoxide, it's not going to count against you. I am a scientist and I am awful at spelling, as noted by many misspelled words on your notes, syllabus, and other places around the room. So dinitrogen pentoxide. There is only one rule for when it comes to naming covalent compounds, and that rule is that the first element never receives the prefix mono. Because simply saying that the element is there automatically denotes that there's at least one. If the second element is the only one, if there's only one of that element, you do have to put the mono. So mono really applies only to the second element. So for example, here I have sulfur and oxygen. Since oxygen is the second element, we change the gen to "ide," so this is oxide. I have 1 sulfur, but since it's the first element, I am not going to put the prefix mono here. That's not right. You don't put that prefix there. If you do put that prefix, I will count it against you. Never put the prefix mono with the first element. So we just say sulfur. I have 3 oxides, so this is sulfur trioxide. Really quick, I want to cover this, just to cover my bases with you. The difference between an ionic compound and a covalent compound when it comes to the nomenclature and what each name particularly means. When you're talking about an ionic compound, this is sodium chloride. If you were to look at at the structure of sodium chloride, you would have a whole bunch of sodiums surrounded by a whole bunch of chlorines, because the sodiums have a positive charge and the chlorines have a negative charge, and they're attracted to one another. The simplest ratio of one to another is actually what the formula represents. And that's for an ionic compound. In an ionic compound, this simplest ratio, sometimes called a formula unit, is the simplest ratio of one element to another in the ionic compound. In covalent compounds, we're actually talking about molecules, where one sulfur atom is bound to 3 oxygens. And it's not as though those oxygens are bound to other sulfurs. They are on their own and satisfied with the bonds that they have with that sulfur atom. There is no formula unit for a covalent compound. There is for an ionic compound. This is not entirely necessary that you know for the first unit. You may not even need to know it for the second or third, but this will eventually come up, and you should know the difference in why I might say formula unit, or I might say the formula for an ionic compound, or the molecule name for a covalent compound. They are different.